All right, so our last day of graphing is going to focus on the tangent and cotangent functions. And just like with cosecant and secant, we are going to have asymptotes with tangent and cotangent, because remember, tangent is sine over cosine. So that means its tangent's undefined when cosine is equal to 0. So that's when we're going to have our asymptotes. So when is that? When is cosine equal to 0? It's going to occur at multiples of pi over 2. Multiples of pi over 2. Now the period for tangent is pi, because that's the distance between your asymptotes, your vertical asymptotes. Domain is all real numbers except, so x cannot equal pi over 2 plus, and the way we write multiples of pi is we would write n pi, because that also addresses the negative sides as well, because you can say plug in -2 for n, and then get to the negative x values or negative multiples for pi. Now, if we look at the graph, you can look and see that the y values go all the way down to -infinity and up to positive infinity. And then your vertical asymptotes, just like with other functions, x equals pi over 2 plus n pi. So it's going to be easier to visualize that when we graph it. So sketching tangent functions, we're going to follow these steps here. Find the period, and again, the period is the distance between our asymptotes. And instead of it being 2 pi over b, it is pi over b. That tells us how often we're going to have our vertical asymptotes. And then find vertical asymptotes. We set the angle part, the inside, equal to -pi over 2 and equal to positive pi over 2, and solve it, and that will tell us where 2 consecutive vertical asymptotes are, and then we can use the period to find other ones. Now, halfway between the asymptotes, we're going to cross the midline of the graph, right? And then, so that midline term is coming back. And for the most part, our midline is going to be the x-axis, but I just want you to be aware that if we are shifting up and down, okay, we're going to be crossing the midline halfway between the asymptotes. Now, the quarter points between the two asymptotes, or the halfway between our midline intercept and our asymptote, our graph will be the absolute value of a, or amplitude, above or below those, below the midline. When a is greater than 1, we go up into the from left to right, and if a is negative, we go down from left to right. So this one up here, in between the asymptotes, we're going up to the right. So that tells us that this is a positive tangent function. So it would look, a positive one would look like this, and a negative one would look like that. So example 1, we're going to graph 1/2 tangent of x over 3. So if you want, you can rewrite this to make it a little bit easier to see. Whoops. 1/3 x. So now you can see your b value a little bit easier. So down here, we're going to do all of our work for this. So I like to find the asymptotes for tangent first. So what we're going to do is we're going to set that angle 1/3 x. We're going to set that equal to -pi over 2. And we're going to set 1/3 x equal to positive pi over 2. And then we're going to solve for x. Well, to do that, we multiply both sides by 3. we get x equals negative 3 pi over 2 times 3 times 3. X equals, that will be positive 3 pi over 2. So those were that's where our first asymptotes are going to be. Now let's go and draw those asymptotes. So let's make each of these boxes pi over 2. So 3 pi over 2 will be here, and negative 3 pi over 2 will be there. So these are our asymptotes here. Now look at the period. The distance between them is 6 of these blocks, or we could subtract these two to find the distance, or to find the period, we can do, the period is going to be pi over b 1/3. Well, that's going to be multiplied by 3 over 1 instead, so we get pi times 3 over 1, or 3 pi. So every 3 pi, this function will repeat itself, or the way we drew it, 6 blocks here. So 1, 2, 3, 4, 5. So our last asymptote is going to be, off the grid a little bit. And 1, 2, 3, 4, 5, 6, off the grid a little bit. So now what we're going to do is make our y value. So let's just do 1/2 here, negative 1/2 there. Now our midline is y equals 0. So we said that halfway in between our asymptotes, we're going to be at the midline. So halfway between my two leftmost, there's a point. Halfway between the middle asymptotes, and then the halfway point between here, 1, 2, 3 units. So our amplitude is 1/2. So now the quarter points between the asymptotes, or halfway between the asymptote and that midpoint, we are either going to be at negative 1/2 or positive 1/2. Since this is a positive tangent function, it should go like that in between our asymptotes. So halfway will be right here, and halfway in the other direction will be there. So our tangent will look like that. And then same idea here. So our tangent, I don't like that. It'll be like that, and then same idea. Same idea here. So I call these the quarter points, but like I said, you could think of it as the midpoint between your middle and your asymptotes. So we were only able to draw like 3 cycles on this graph because our period was large for this problem. All right, now for letter B, we have a lot going on here. First, it's a negative tangent, so that means our graph is going to go like that, down and to the right between each asymptotes. We have a horizontal shift of pi over 4 to the right. So let's go ahead and figure out all of our information here. Now our asymptotes, we're going to take this and set it equal to negative pi over 2, and set it equal to positive pi over 2, and solve that, and that's going to get us our first 2 asymptotes. So distribute the 2, we get 2x minus pi over 2 equals negative pi over 2. Add pi over 2 to both sides, we get 2x equals 0. So x equals 0 is one of our asymptotes. Then the same thing over here, distribute the 2, we get 2x minus pi over 2 equals pi over 2. Add pi over 2 to both sides, we get 2x equals pi over 2 plus pi over 2 is 2 pi over 2, or pi. And then x would have to equal pi over 2. So those will be our first asymptotes at x equals 0 and x equals pi over 2. Now, we have to make a decision about our scale or our grid marks. I wasn't real happy with this one, how we had, this point that was not nicely on a grid mark in the x and y direction. So over here, because we're going to do quarter points, I'm going to make this right here pi over 2. So then that way I have 4 equally spaced intervals. I have 4 marks in between our 2 asymptotes. Now, you can't always do that. Looking back at this one, we might have been able to make it work. So the problem with doing that maybe with this problem is because our period was 3 pi and our asymptotes were at a multiple of pi over 2, it was going to be hard to make both of those fit and have nice consistent markings on our graph, where here, our asymptote is 0 and pi over 2, and then our period is going to be pi over b. Well, our b value is 2, so pi over 2 is our period. So that is a nicer fit altogether. So now we know every pi over 2, we're going to have an asymptote. So 1, 2, 3, 4, this will be pi. We're going to have an asymptote. Then if we go backwards 4 marks, 1, 2, 3, 4, that'll be negative pi over 2, and we have an asymptote. 2, 3, 4, negative pi, and we're going to have an asymptote. Then we have 3 and negative 3 for our y coordinates, or our y portions. So now in between each asymptote, the halfway mark, we're going to be at the midline, which is going to be the x-axis, because we don't have a plus or minus on the outside. Then at the quarter points, we're going to be either at positive 3 or negative 3. And again, because this tangent's negative, between each asymptote, it's going to look like that. So now here, we're going to go there and there. Here and here. Then here and here. And again, we want to make sure we don't touch our asymptotes. That would not be good. So our graph will look like that. We were able to fit more cycles on this one because the period was just pi over 2. All right, now if we look at the next page with the cotangent function, you may look at that and say, well, it just looks like a reflection of the tangent one, or it looks like a negative tangent function. However, the difference is, since sine is in the denominator, whenever sine is equal to 0, that is when we have our vertical asymptote. So sine is equal to 0 at multiples of pi. So 1 pi, 2 pi, 3 pi, those all have a sine value of 0. So that in the period is going to be pi as well for the regular cotangent function. Domain, x is not equal to pi plus n pi, so multiples of pi. Range is also negative infinity, comma infinity. And our vertical asymptotes, x equals n times pi. So cotangent might be a little bit easier because the asymptotes occur at multiples of pi instead of multiples of pi over 2. So just like with tangent, your period is pi over b, and again, the distance between the asymptotes. And to find your first 2 vertical asymptotes, you're going to set the angle equal to 0 and equal to pi. Instead of up here, we set them equal to negative pi over 2 and positive pi over 2. And just like with tangent, graph crosses the midline halfway between the asymptotes, so that midpoint again. And like tangent, our graph will be the absolute value of A above or below at those quarter points. And like I said earlier, the cotangent function looks like a negative tangent function, so what you got to watch out for is that when A is negative, the graph is going up into the right. So when A is negative, it looks like a tangent function. And then when A is positive or greater than 0, it looks like a negative tangent function. Like I said, opposite of the tangent function. So we have one graph here, negative 1/2 cotangent of x plus pi over 2. And just like with sine and cosine graphs, when we shifted left or right, you could say, well, if we shift left or right, it's going to look just like a sine function, even though the original was cosine. And this one could look just like a tangent function because we are shifted left pi over 2 units. So let's do our asymptotes. So x plus pi over 2 equals 0, and x plus pi over 2 equals pi. And then we're going to solve that. Subtract pi over 2, we get x equals negative pi over 2. And then if we subtract pi over 2 from this one, we get x equals positive pi over 2. And then our period is going to be pi over b, pi over our b value of 1. So we have pi. So I'm going to make each of my each tick mark here, not pi over 2, but actually pi over 4. So this is going to be positive pi over 2 because I've gone 2 marks. And this will be negative pi over 2 because I've gone 2 marks. That gives me 4 markings, 4 tick marks between these, or 4 spaces between these. So now every pi, we're going to have another asymptote. So another 4, 1, 2, 3, 4. We're going to have a vertical asymptote here, a vertical asymptote here, vertical asymptote here, another for 1, 2, 3, 4, another asymptote there. And that's as far as I'm going to go. I'm not going to go off the grid on this one. Right? Then we have to do, I'm going to put 1/2 right here and negative 1/2 there. So halfway between these asymptotes, I'm going to use a different color. Halfway between these asymptotes, I'm going to be at the midline. Our midline is still y equals 0 because we didn't shift up or down at all. And then, again, because it's negative cotangent, at the first quarter point, we're going to be at the negative, I call it amplitude, but it's really not the correct term, but our negative a value, and then positive a value. So it's going to go up and look like a tangent function. Okay. And then here and here, it's also going to look like a tangent function. So I think that graphing tangent and cotangent is probably the most difficult because you really have to think about how you want to draw your scale so that everything fits nicely. So that's it for tangent and cotangent. Thanks for watching. Make sure to like and subscribe.